Hey guys, today we're going to be looking at identifying linear and nonlinear functions. There's three ways that we identify linear and nonlinear functions. The first one is a table, the second one is a graph, and the third one is an equation. So by the end of the day, I need you to go back and reflect, do I know what a linear function looks like in a table, in a graph, and in an equation? If it doesn't look like how it's supposed to, then it's going to be labeled as nonlinear. All right, let's get started with our definitions. All right, a linear function, keep it simple, has a constant rate of change. What do we call a constant rate of change? Slope. It makes a line, it has a slope, it increases or decreases at the same amount each time, and it can be put into the form of y equals mx plus b. X has to have an exponent of 1. A nonlinear function just doesn't have that constant rate of change, doesn't meet all those requirements that I was talking about. So doesn't make a line in a graph and doesn't have that x with the exponent of 1 in an equation. So let's go ahead and look at our first example in a table. Does this graph or table represent a linear or nonlinear function? And explain. So we're looking for that constant rate of change. Down by 5, down by 5. Down by 5. Constant rate here. Up by 7. Up by 7. Up by 7. Constant rate here. So this is linear because it has a constant rate of change, slope. Let's go to example 2. I always start with the y. I don't know why. I always start with the y. And make sure you're looking very carefully. The x's need to be going by the same in order to really determine if this is linear or not with the table. Okay, so don't let the tables get to you. Remember, if you graph it and it doesn't make a line, you know it's not a function if you're struggling with the tables. So this goes down by 4, down by 4, down by 4. Up by 2, up by 2, up by 2. So linear because it has a constant rate of change. All right, graph. Graph should be super easy, straight to the point. Is the graph a line or not? If it's a line, it's linear. If it's not, it's not. This is not linear. So non-linear because it does not have a constant rate of change, aka doesn't make a line. So we talked about tables now. Tables, you're looking for constant rate of change. We've talked about graphs. You're looking for them to be a line. They need to be a line. And remember, it's one line. One. Now let's go ahead and look into equations. Does the equation represent a linear or nonlinear function? Let's look at this first one. Y equals m is 1. X plus b, linear, because x is only to the first x. X is only to the first exponent, so it's linear. And don't worry, I'll go over this when we get to number 6, what I'm talking about in exponents. This one, linear. Because this x right here only has that exponent of 1 right there that we don't write because x only has that first exponent. 6, nonlinear, because x is squared. Right here, x has this power of 2, So it doesn't have that first exponent. It's not linear. So our third one, equations, they need to have exponent of 1 in order to be considered linear. All right, go ahead and try these on your own problems. Your essential questions ready to be answered. Please play your video when you're ready to check them. Here's what we should have got. Linear makes a line. Okay, nonlinear doesn't have that constant rate of change. It goes up. Sorry, it goes down and then up. So that's your big indicator. All right, your checkpoint's ready to go. I hope you guys are having a great day. Thanks for being here.